A warm welcome to everyone. I am Toon Modok and currently I am pursuing MSc in Applied Mathematics from IIEST Shibpur. So today the topic that I have chosen is limits, which is the beginning of differential calculus, and once we understand the topic of limit we can move forward towards continuity and differentiability. Now when we are trying to study about limits, we are studying about functions which are real values, that is functions f which are defined from R to R, that is set of real numbers where R is the domain and the R is the codomain. So why these functions are called real valued? Because if we look at f of x, the image of x where this x also belongs to R, so f of x is also belonging to R. So the function f is actually taking real values. That's why we are saying it is a real valued function. Now symbolically, what do we mean by limits? So first I will write down the expression, that is if we have limit x tends to c, f of x is equals to L. This means that when our x is approaching or becoming closer to c, the value of the function f of x, that is the value of the function f at the point x, is actually approaching L. Okay, now for example, suppose I take a function f of x given by x square minus 4 divided by x minus 2, and here x is not equals to 2. Why are we taking this condition? Because if we put x equals to 2 here, the denominator would become 0 and this function would be undefined. Now let us look at the graph of this function. So if we draw the graph of this function, this is like this. The graph kind of looks like this. Okay, now this is our point 2 and this is our point 4. At the point 2, let us just join this. This is our graph. Now if we look at, see, take any point that is nearer to 2, either this side or this side, then just extend it and then just see. Similarly I would extend this and see. So see, when our x is approaching 2, the value of the function f of x is actually approaching 4. Now how are we supposed to compute the limit? Now to compute the limit, we are going to have consecutively two one-sided limits. That is, we can approach the point 2, in this example only, we can approach 2 by two directions. Either we can approach 2 from the left hand side of the x-axis or from the right hand side towards 2. So to calculate or check if a function is having a limit at a point, we need to check two one-sided limits, that is the left hand limit and the right hand limit. So for example, let us take a basic example. I am going to show how we are going to compute. Suppose we have a function f of x which is, say, defined as x plus of 2 when x is not equals to 1 and 0 when x is equals to 1. Okay, this is our number line. This is suppose our point 1. First I am going to take the right hand limit and then, left hand limit, then I am going to take the right hand limit. Now for the left hand limit, how I am going to write it? As a notation, it would be limit x tends to, I am tending to 1, checking the limit at the point 1. Now I am approaching 1 from the left hand side. So symbolically I am going to write minus over here to denote that I am approaching from the left hand side. And see, when our point x is approaching 1, that means it is closer to 1 but not 1. So from this branching of this function, x value is 1 but approaching 1, not 1. So we are going to take this x plus 2. So f of x would be x plus 2. This is what we put. And then how to calculate? Wherever x would be there, simply replace x by 1. So it would be 1 plus 2, that is equals to 3. Similarly, this is our left hand limit. Now suppose we want to calculate our right hand limit. Symbolically we are going to write limit x tends to 1 from the right hand side. So we are going to write a plus over here and x plus 2y, because again x is closer to 1 but not equals to 1. So this value would be taken and this again replace x by 1. I am going to 1 plus 2, that is equals to 3. Now I am going to do a simple change in this and to show that in this case we saw that the limit is existing. Now how to check if the limit exists or not? Take the same function, just little modification I am going to do. Suppose we have a function f of x defined as x minus 2 for x is less than 0, 0 when x is equals to 0, and we have x plus 2 when when x is greater than 0. We are going to check the functions limit is existing at the point 0 or not. Let us calculate the left hand limit. Is what? Limit x tends to 0 negative. Now 0 negative means near 0 but less than 0. So x minus 2. Put 0, we are going to get a minus 2. Now calculate the right hand limit. We are going to have limit x tends to 0 plus x plus 2. Okay, wherever x put 0. So get a 2. Clearly we can see this is not equal. So the left hand limit and the right hand limit are not equal. So limit of this function, particular function f of x, is not existing at the point 0. So this is a simple way where we can calculate or compute the limit at a point for a function. Now I would like you all to try one question, which is this. Suppose we have a given function f of x that is equals to x by mod x. Okay, you have to check if the limit is existing at x equals to 0. Just one hint, mod x. Now this particular mod x function can be written into 3 parts. Like it is branched into 3 parts. That is, mod of x value is broken into 3 portions. Mod x is actually minus x when x is negative. Mod x is 0 when x equals to 0, and mod x is x when x is positive. So you have to check if the left hand limit is equals to right hand limit or not. If it is equal, then the limit is existing at the point 0. If not, then it's not existing. And to check that, again you have to simply break mod function and then check if the limit is existing. Okay. Next we are going to talk about certain algebraic operations that we performed with the help on limits. Like for example, we have two functions f of x and g of x. Okay, and at the point A, suppose both the functions, the limits of both the function is existing. Okay, then the limit of the function of summation of fx plus gx can be broken down individually, and limit x tends to fx plus limit x tends to gx. Similarly, if we have multiplication, then again this whole limit will be broken down and can be written separately. Similarly, for our division rule is also applicable. This is what becomes, but here you have to keep in mind that the denominator is non-zero. Then this last operation will also be valid. This can be checked using very simple examples. Now I would like to end the video with a very important example, which is how should you solve limit questions when the form is actually 0 by 0 form. When we would be doing differentiation, after we learn that, then there is a very famous rule, that is L'Hopital's rule, that we might be able to apply. But now I am not going to show that over here because we are only talking about limits. But without L'Hopital, certain sums can be solved. How do we do that? Suppose we have an example, limit x tends to 2, x cube minus 4x square plus 4 of x divided by x square minus 4. Now, wherever x is here, you replace x by 2. Then this is what? 8 minus of 16 plus of 8, which is 0. And again, putting 2 in denominator, it's 4 minus 4, 0, which is our 0 by 0 form. So directly, we cannot replace x by 2. Now what do? We can do is simply simplify the expression. Look at the numerator portion, it can be factorized. So I'm just going to factorize that. So if you simply take x common, so we are going to have x and x square minus 2x plus 4, which would give x minus 2 square, divided by x square minus 4, a square minus b square, which is a plus b into a minus b. Okay, this 2 cancels, so we have limit x tends to 2, x minus 2 divided by x plus 2. Now over here, wherever x is, simply replace by 2, this becomes 0 and this becomes 4, so 0. That is it. So now we saw how we are going to solve. Now It is very interesting to note that what will happen to the limit of the function, the existence of that, if we simply interchange the numerator and denominator. So this is the task for you all, that you have to check if this limit is existing or not for this function. We have simply interchanged the numerator and denominator and find out if the limit is existing at the point 2 or not. So that is all for today. Thank you so much, and